Welcome back to the deep dive. Today, we are cutting through the noise on a piece of garage folklore that just seems to hang around forever. You know the one. That persistent, notorious idea that when it comes to engine oil, thicker always means better protection.
It's a really deeply ingrained belief.
Mm-hmm.
And, to be fair, it kind of made sense decades ago. Manufacturing tolerances were just looser then.
Right.
But the moment you apply that old wisdom to a modern engine, you were just inviting some serious trouble.
And that's what we're here for today. We want to explain exactly why the downsides of using an oil that's too thick or, on the flip side, too thin, far outweigh any supposed benefits you think you're getting.
Exactly.
Our mission is to prove that those numbers on the oil bottle, they're not just suggestions, they're engineering mandates. And here's the core takeaway we've found.
Yeah.
The problems from using oil that's too thick are basically the inverse of the problems from using oil that's too thin. It's a zero-sum game, and it's all decided by your engine's design and, well, the climate you live in.
That's it. It's a tightrope walk. And it all starts with just understanding viscosity, the oil's resistance to flow, and why the engineers picked those specific numbers for your car in the first place.
Okay, so let's unpack that numbers game. We see a common modern grade, something like 0W20.
Right.
We know the W stands for winter, and it gives us the cold viscosity, the 0, and the hot viscosity, the 20. So let's set up a scenario. Someone with a brand new car that demands 0W20 decides they want that old school protection, and they pour in 10W30 instead. Where does the trouble begin?
It begins instantly.
Yeah.
I mean, before the car even warms up, that 10 in the 10W30 means the oil is just significantly thicker than the required 0W20 when the engine is cold.
So in cold weather, it's like putting molasses in a system that was designed for water.
That is a perfect analogy. That's exactly it.
So what's the actual tangible consequence of that sluggish cold flow?
It's all about slower lubrication on startup. When you turn that key, those first 3 seconds before the oil pump fully pressurizes and gets fluid everywhere.
Yeah, that's the critical time.
That is the most critical period for friction and wear. So if that thick 10-weight oil is fighting gravity in the cold, it just moves too slowly. You get increased metal-on-metal wear during those cold starts.
And I've heard if it gets really cold, it can actually make it hard to start the car at all.
Oh, for sure. The starter motor might actually struggle to turn the engine over because it's physically trying to push that thick, cold fluid around.
Now, here's where it gets really interesting, at least to me. Our simps say that if you skip 2 grades, or more like going from a required 0W20 all the way to a 15W30, the harm grows exponentially. Why such a massive jump in risk?
It's purely down to how engines are made now. Modern engines, especially these, turbo 4-cylinders, have drastically smaller gaps, tighter manufacturing tolerances.
So you mean the space between, like, the bearings and the crankshaft?
Exactly. In those critical areas, they are built for extreme precision. We're talking about incredibly small clearances.
So those bearings just weren't designed to accept a thick, slow-moving oil. The thickness of that protective film is engineered specifically for a 20-weight fluid at operating temperature.
You've got it. And when you try to force a thicker oil into those tight passages, it physically cannot flow quickly enough or even completely into the spaces where it's needed most.
Okay, so it's not just about poor protection.
No, it's also about the engine wasting a huge amount of energy just trying to shove that oil through these tiny passages.
Yeah.
Engineers call that pumping losses.
Pumping losses. That sounds incredibly inefficient. Can you, give us an analogy for what that feels like inside the engine?
Yeah, sure. Think about trying to drink a really thick frozen smoothie.
Okay.
But you're trying to drink it through one of those tiny little coffee stirrer straws.
Right. Impossible. You're just sucking as hard as you can and almost nothing is moving.
Exactly. You are working against massive resistance.
Yeah.
That is what your engine's oil pump is doing. And all that wasted energy, it doesn't just disappear. It generates heat.
So higher heat means higher stress on everything.
Precisely. And that extra heat leads to a few things. You get higher overall engine temperatures, which can cause premature sludge formation. And critically, you'll see a noticeable drop in your MPGs because your engine is literally fighting the very fluid that's supposed to protect it.
So you've just successfully lowered your fuel economy and shortened your engine's life, all for a myth.
All in the name of a misguided myth, yes.
Okay, so using oil that's too thick means slower lubrication, more friction, more heat, and worse fuel economy. Got it. Now let's flip this. We said the risks are inversely related.
Right.
So moving to the other end of the spectrum, Thinner oil can't be perfect either, especially if the engine wasn't designed for it.
No, it is absolutely not without its own disadvantage. This is the opposite mistake. Let's take scenario 2, the hot weather risk.
Gotcha.
Let's say you have an older engine that calls for 5W30,
Mm-hmm.
but you've been reading about modern efficiency, and you decide to use 0W20 because, it's a full synthetic, it's better for cold starts.
In theory, that 0W20 would be great for a cold morning. But what happens when that engine gets really hot? You're idling in traffic on a 100-degree day.
Well, you have to remember, all oil naturally gets thinner as it heats up. The 5W30 was designed to maintain a stable, let's say, 30-weight film thickness at operating temperature, which is around 212 degrees Fahrenheit.
Right.
If you replace that with 0W20, which is already thinner to begin with, it just becomes dangerously thin when the engine is fully heat-soaked.
So it's flowing beautifully, but it just doesn't have the substance to keep the metal part separated anymore.
You nailed it. When that oil film breaks down under heat and pressure, you get metal-to-metal contact. And this results in just devastating wear on bearings and other internal parts. You've basically traded better cold start performance for the risk of catastrophic engine failure once everything gets hot.
That seems like a much more immediate and, frankly, severe problem than the slow degradation from thick oil.
It can be, yes. And what's more, thin oil can create serious systemic issues because it just can't hold the necessary pressure.
What kind of systems are we talking about?
The most common example is variable valve timing, or VVT.
Ah, right.
VVT systems use hydraulic pressure from the engine oil to actually adjust valve lift and duration. If the oil is too thin, the pressure drops below what's required, and the VVT system it can't work right.
And what would you, the driver, notice?
You'd probably notice rough running. You might see the dreaded oil warning light pop on.
Yeah.
Or you could hear distinct clatter and valvetrain noises, which are basically just warning signs that parts are grinding together when they shouldn't be.
So it sounds like whether you go too thick or too thin, you're causing damage. It's just through different inverse mechanisms. One is a failure to flow, and the other is a failure to maintain film strength.
That summarizes the duality perfectly. Thicker oil starves the engine at the start and builds up heat. Thinner oil is great when it's cold, but it breaks down when it's hot, and you lose pressure and protection.
So given this very tight window of required viscosity, is there ever a situation where switching your oil grade is actually a good idea?
There is one crucial exception, and it actually reinforces our main point. You have to stick to the owner's manual.
Okay.
Switching is only okay if the manual itself explicitly allows for different grades based on the climate or how you use the vehicle. For instance, a manufacturer might suggest 0W20 for, extremely cold northern climates, but then allow you to switch to 5W30 if you live somewhere perpetually hot, like the desert Southwest.
So in that specific case, you're not choosing a different oil based on a myth. You're choosing it based on an actual engineering allowance from the people who made the car.
Correct. You're raising the high temperature protection level because the environment demands it. And the engine was designed and tested to handle both of those viscosities under those specific conditions.
Any switch outside of what the manual suggests is just...
By just rolling the dice with your engine's highly specialized lubrication system.
So what does this all boil down to for you, the driver listening right now?
I mean, the core lesson here is undeniable. That old belief that thicker oil is better is just fundamentally wrong for modern engines. It's an obsolete myth that completely ignores tighter tolerances, VVT systems, and, the basic principles of hydraulics.
So if you want the best longevity and efficiency,
The best thing you can possibly do is stick with the recommended viscosity at every single oil change. Trust the engineers who built the engine, not the old wisdom from the guy down the street.
you nailed it. The shift in engine design, all those smaller, tighter gaps, it just requires laser-focused maintenance and these incredibly precise fluids.
And, this reliance on thinner, ultra-precise fluids actually gives us something important to think about for the future.
So since every new engine is basically a highly specialized instrument requiring this fluid-level precision, what new quick-fix myths do you think might develop in the next decade?
Well, if the trend continues and tolerances get even tighter, maybe requiring 0W8 or even 0W4 oils,
Would your
they're coming. Will a new generation of mechanics start fighting a new myth? Maybe that this water-thin oil provides too much protection, leading them to upgrade to 0W20, which will then be considered the thick stuff.
It's a never-ending cycle of misinformation just chasing engineering advancement.
It really is.
Something to ponder as you look up your specific oil specs in the manual. Thanks for diving deep with us. We'll see you next time.